This video is going to be about gas cutting, and in particular about propane cutting as a type of oxy-fuel cutting process. As part of this video, we will look into difference between acetylene cutting and propane cutting. We will look into how to set up torch and correct flame, and we're also gonna look into cutting machines, gas cutting machines, and some accessories for gas cutting equipment. Also, as part of this video, we will try to find the answer to one of the most fundamental questions in the gas cutting and the gas welding world. It's which gas should you turn off first when you're switching off your gas cutting equipment. Whether you need to turn off oxygen first, or whether you need to turn off fuel gas off. And we'll have a little experiment that will give us a chance to see exactly what we're actually going to do, what happened with the mixture of gases and so on. So you'll get a chance to basically, we will have a chance to understand the chemistry that happens during explosion. Before I start, I have to clarify a couple of things. First of all you're going to hear in this video is my personal opinion. It's not instruction to you by any means. Secondary, I'm going to be seriously advising you before using any equipment to consult your manufacturer's information and the operation manual before you use any equipment. The third thing what I need to say is the type of gas cutting torch that we're going to be discussing is a gas cutting torch that has 3 pipes, and the mixture of gases happens inside of a nozzle. There are older type of gas equipment that have 2 pipes instead of 3, and the mixture of gases happens due to the little injectors. We will not use that equipment. I don't have one in my possession, and I can't really talk about that because I haven't had much use of it in my experience. In both cases, when fuel gas connected, it gets connected to the bottom connection, and it's a left-hand thread. You can identify it by see those notches in there, and that's what indicates the left-hand thread. And the oxygen connects to top, and basically it's a right-hand thread. You can also establish if you look at the left-hand thread or right-hand thread is by looking at which direction the threads rise into. If it's rising towards right, that's a right-hand thread. If it's rising towards left, it's your left-hand thread. So just a handy thing to know for the future if you ever come across left-hand threads that don't have indication with the notches. You only get them on the fuel lines. I think one of the major difference why some people saying that you must turn off oxygen gas first to switch off this equipment, or you must turn off fuel gas first to switch off this equipment, lies in simple not understanding that there is 2 separate systems and they vastly different to each other. In this particular system, they look very similar. They have both valves, but the mixture in this particular system, we have 3 pipes. Bottom one is the fuel line, the middle one is actually oxygen for a flame, and the top line is oxygen for cutting. And mixture of gases actually happens inside of this nozzle. And if you look into injector type, what you have is, if you look, there is injector somewhere around about between where my hand was, and injector what causes the mixing. So in the injector type of guns, what you actually get is every time when you open up the oxygen, what you will also get is you will get Venturi effect, and you will get suction inside of the fuel line. So when you open up the oxygen, the fuel starts to get sucked into the torch. So if you start off with the turning off oxygen first, that suction is what's actually going away and no longer sucking fuel out of the line. So there is a possibility that some oxygen, even that remains in line from cutting side of things, may actually go into fuel lines and cause all sorts of damage. Again, I have to emphasize that this only applies to this type of torch, and it's unlikely you will ever use one unless you live somewhere in the post-Soviet bloc or your boss really hates you. We already established that in this type of torch with the 3 mixing pipes, the formation of a fuel mixture, the formation of actually oxy-fuel, happens inside of the nozzle. Let's discuss different types of nozzles for propane and for acetylene, because if you do mix if you install wrong nozzle to wrong gas, your torch will not work and it will backfire quite heavily, so that can be dangerous. The nozzle you see me holding in my hand just now is a nozzle for acetylene, and as you can see, they come in the packages with the size of the nozzle written on them. And I don't use acetylene. I don't use acetylene whatsoever. However, it's handy to have nozzle in stock just in case you may end up in a situation where you need one. And considering the cost of it, it's easy to have it. As you can see, each nozzle bears mark that tells you the size of the nozzle, and it also tells you the thickness of material that you can cut with this nozzle. That's universally applied between nozzles for acetylene like this ones and the propane nozzle. So comes up question, how do you differentiate two? Well, the propane nozzles, they actually consist of two parts, internal core and outer housing, and you'll see them in a second once I open up one. There you have it, two different nozzle, propane nozzle and acetylene nozzle. Propane nozzle, you can see the top is slightly different color, otherwise they look very similar, how the all surfaces and everything machined. And as I mentioned, propane nozzle obviously has two parts in it, and also what you'll notice that propane nozzle is actually slightly shorter than acetylene nozzle. It allows acetylene to have longer jet, and it has certain benefits to it, but overall they both can cut pretty well relatively heavy steels, and well within the range whatever you're going to be cutting. Anyway, if you want to know a little bit more about acetylene and why I'm not using, about chemistry and the safety issue with acetylene, I would like to invite you to visit my website, which is weld-delux.co.uk, and in there you'll be able to find a lot more information if you just go to the blog, and there is some other interesting things that you may find interesting too. Okay, so back to our video. The nozzle, as you can see, bears the marks, and box also tells you that this particular nozzle is 1/16 of an inch. It's a diameter of a cotton jet of oxygen. So based upon a graph or on the table, you can work out what sort of thicknesses you can cut with this particular nozzle. As you can see, it's a rather strange table because the diameter of a cotton jet stated in imperial, and the thickness of material that can be cut stated in millimeters. So for those of you guys who lives across the pond, I'll just briefly try to go and give you rough ideas what's what. So 6 mil, it's about quarter of an inch. 12 mil, half an inch. 75 mil is about 3 inch. 100 mil, about 4 inch. 150 about 6 inch. 225 about 9 inch, and 300 mil probably about 12. This time let's look a little bit more in depth on molecular level what's happening during burning of propane gas. Propane gas, just like any other hydrocarbon, organic gases like methane, propane, or there is 10 of them. In a similar way to petroleum oils, all that you actually get in burn, what you get heat from, is actually from reaction of oxidization of hydrogen. And propane has a chemical formula which is C3H8, meaning that there is 3 atoms of carbon that hold around themselves 8 atoms of hydrogen. So if we write expanded formula, what we would do to write something like this, like we have 3 atoms of carbon, and each one of them, each atom of carbon has a valency of 4, which is mean it can make 4 connections with other atoms. And I'm just indicating them with these little lines, so it shows you lines for a valency. So 1, 2, 3, 4 is a valency of each atom, and there is 3 atoms in there. So I will just draw little dots in between 2 atoms of carbon to indicate like if they're holding hands together, because there is one valency coming from each atom of carbon. And then on the end of this valency line I will put hydrogen. So as you can see, these hydrogens are sitting there because hydrogen has a valency of 1, so it connects to pretty much to the carbon, and it's open to connect with anything else if a more potent molecule will come, atom, sorry, if more potent atom will come in, and the hydrogen will be ready for reacting. The hydrogen oxide, which is water, is formula is H2O, and we know from this, we know that each oxygen atom will actually lock 2 atoms of hydrogen. So if we have 8 atoms of hydrogen in our propane mix, in our propane molecule, which is C3H8, we know that we need to have 4 atoms of oxygen in order to bond all hydrogen available within that gas and convert it all into hydrogen oxide, which is, as I said, the water. Let's draw a graph which will help us to understand a little bit more in theory which valve should be shut off first when we turn off oxy-fuel cutting equipment. This graph going to be energy release graph during combustion of propane and pretty much any gas and the oxygen. So the graph will be divided into 2 sections. Left hand side will be our hydrogen content side, and the right hand side will be our oxygen content. So, and what will happen at the point of the best combustion, the biggest amount of energy will be released. So we can probably presume that our graph will look like a spike, which starts from hydrogen, from 0, where's pure hydrogen and no oxygen, so there is not enough to combust. And then once you add a little bit oxygen to it, then the biggest combustion, the biggest amount of energy at the spike, and then it goes all the way down to a situation where absolutely no fuel left, only oxygen. So at this stage, if we have 0 in there and 0 in there, what we'll have is the highest energy peak at somewhere in the middle. I think everybody will agree on that one. And just draw a little explosion right on the top, because that just to indicate the highest amount of energy released. It is important to notice that our fuel side of graphic is actually low energy state, and our oxygen side of graphic is actually high energy state. What I mean by that is, at given volume of the atmosphere, the only amount of fuel will ignite is equivalent proportional to the amount of oxygen that you have to bind that fuel. On the other hand, on the other side of graph, in the oxygen-rich atmosphere, any fuel that you ignite in there will always ignite completely because of abundance of oxygen, all the way down to the point where there is no fuel to ignite because only oxygen left. And that means that when we shut off oxygen first, when we reduce oxygen, we actually operate in a low energy state. We operate in a fuel-rich environment, not an oxygen-rich environment where things will ignite completely. So we can control combustion and slowly down bring combustion to nothing, bring combustion to the 0. And that's the reason why I think we should always turn off oxygen off first and then fuel gas in this type of oxy-fuel cutting equipment. I think you're probably going to agree that theory is nothing without practical experience. So what I'm going to do, I'm going to put a rug inside the device and hold my torch in there. And I have reduced oxygen pressure. I equalized oxygen pressure and the propane pressure to be the same, so I can control my timing. I know I need to have issues of fuel to oxygen for 1 to 4, 1 fuel to 4 oxygen. So I can actually control that by timing, since pressures in my supply are equal to each other. Then I have both set of balloons, just a clear balloons, wherever was cheapest on eBay. And what I'm going to do now is I'm gonna inflate them with the oxy-fuel mixture, and then we'll ignite and see exactly how it behaves. So I'm going to mark out every balloon, and as I said, I will control it by timing fuel to amount of gas I put in simply by counting the amount of seconds. Those are really small balloons, and as somebody I spoke with mentioned, it's really handy that you bought really small balloons. So in this part, in the first one, we'll put quite a lot of fuel gas, indicating lots of fuel, low energy mixture, and then a small amount of oxygen. So I'm gonna tie that up, just put a knot in it, and then mark it out. I wasn't sure if it's gonna be visible on the camera, but it seems to be like it's fine, even on the clear balloons. So this is gonna be our number one, fuel-rich mixture. So the second one we're going to make proper 1:4 ratio mixture, where 1 fuel and 4 oxygen. I was using the burner, so it's a bit hot to hold it on, but that's fine. So 1 second, 1, 2, 3, 4 seconds. And the same thing again, I'm just gonna mark it up. And obviously later on we will ignite them and you will guys see exactly how each one of them is behaving. An important thing to know is the more energy you release, the more noise will happen, more bang you will get, and also more heat will be produced. So the noise is actually something that we can actually measure, amount of energy released from the system. So this time we're going to put very little fuel and lots of oxygen. And that will be our number 3. I moved away my gas burning equipment, so now I'm gonna take number 1 and I'm just gonna hold it in the vise. I just for everybody who's curious to see whether it's light or heavy, you can see the propane and the oxygen, they're both very heavy gases, so the balloon falls, and you can see how it's hanging in the vise as well. And quite natural, I don't want to have my hands nowhere near the thing, this balloon when it ignites, and I'm going to use thick welding rod with a bit of paper on the end of it, and basically use that to ignite the balloon itself. The paper was a little damp, and that's the reason why I didn't really want to ignite that well. So I better shut up so you can actually hear exactly what happens when flame hits that balloon. Yeah, there we go. So this time I'm going to put number 3, which was oxygen rich balloon, and I will cut the video so it shows one explosion after another, so you can actually compare fuel rich mixture to oxygen rich mixture. Going quiet again. You probably have noticed much louder bang on the oxygen rich atmosphere. And here's side by side, starting with the fuel rich mixture first. Naturally we are going to try number 2 balloon that we inflated, and we will see how much stronger the reaction will be. Have to say guys that you may want to lower your volume down, especially if you're listening in the headphones. Yeah, the proof is in the pudding. You'll hear a difference right away, and you will notice the difference in the energy released. And again, I'm gonna put them side by side for comparison, so you actually hear one after another and be able to compare how it works. Oxy-fuel flame does not produce high levels of UV radiation like what arc welding does. Therefore, you can get away with the glasses like this. They're about shade 5, around about that sort of mark. You can get them slightly lighter as well. And it really depends on intensity of light outside. If you work in the dark hours, it's easier to work with the lighter glasses, because you can see what's happening around you a lot better than working in the bright. When you work in the bright sunlight, obviously darker glasses help. There are different attachments available for your cutting torch. Like I'm going to fit circle cutting attachment at the moment. Quite often, if you had your torch in for a while and due to heat and expansion and contraction, what you get nozzle that just gets stuck inside of a torch. So it's handy if you have a situation like this, not to prise in the nozzle, because you will just damage the seat, and all you need to do is just have a little shock and knock it with a hammer, but not on the area where threads are, but more on the heel of the torch itself. In this case, you actually don't need to do it. So we fit attachment on, and then it just gets threaded into the torch. Obviously, if you use acetylene for cutting, then you'll just simply take lock and nut off and replace it with this attachment. So it doesn't need to be super tight, it's just hand tight, and it's fine. As you can see, there is a little wheel right beside the flame nozzle, and that wheel allows me to ride on the material and cut circle as I need to with a good control. The flame, you just add enough heat to cut the thickness of material that you need to do. That kind of comes with experience, but there is a ways and means to judge it, and you adjust mixture such that you burn all fuel gas with your oxygen, and when you hit cutting oxygen, there should be nice jet. As you can see, if this jet is nice and even and straight, quite prolonged, that means that you have cutting oxygen which will cut nice and evenly. You want your really hot flame not to grow every time when you hit oxygen, because if that happens, that means that your oxygen pressure is slightly too low, and you want to be able to maintain the heat while you're cutting with your torch. So when you adjust your mixture just right, you will see the distinctive glow in the brightest, in this hottest part of the flame, right at the end of the nozzle. It starts to have very distinct glow to it. I think I have a record of it in the future somewhere further along, so I'll make sure it's actually fitted into this video. It is always good to use some sheet of steel underneath where you're cutting, just to make sure that hot molten steel doesn't damage the concrete that you're actually working on. And as you can see on the plate, I have a couple of marks in here. That's where I was setting up my equipment, just to make sure I'm getting the right diameter for cutting. And to simplify the whole thing, you can actually even drill a hole, so you have a good starter from which you will start cutting your steel. When you cut in thin steel, it's relatively easy, because even if your torch angle isn't 100%, that's not really a problem. But if you cut in something heavy, like this one is a 25mm or an inch steel, then if your angle is not 100%, then you start to get taper in your cut. So later on in the video, I'll show you way to deal with it when you cutting something like a bit heavier and you still want to cut manually with a torch. You probably realized that this video been sped up just to show you exactly how circle can be cut. In this particular frame you see 40mm plate, which is just a little over inch and a half, and we will cut it manually, so I'll explain it. I'll show you everything I was trying to explain before. It is a good idea to actually mark your lines really well, and sometimes if you have older or rusty material, it helps to run a grinder and basically with a thin disc like 1mm disc, just to cut a line so you'll be able to follow it, because if you just mark it with a chalk or a pen on top of rust, every time when you apply heat from a gun, it will actually start popping off and the loose bits of rust will fly away along with the mark that you made. So run a little cut and you'll be able to follow that very easily afterwards. It also helps if you preheat it. If you don't have much experience, if you preheat that line that you're going to cut on the heavier steel, but do not preheat it from the top, preheat it from the bottom, so the bottom of the line where you're gonna cut is actually slightly warmer. Once you have a little bit more experience, you'll be happy enough to just take on it and cut it as it is. As you can see, wherever possible, I use the gas cutting machine to actually cut straight lines, and the machine only cuts straight lines in my case. So if I want to cut anything curved, I have to cut it manually, and for that, as I mentioned before, I need to keep a torch perfectly square to the piece that I'm cutting. Otherwise I'm getting a taper and my cut is gonna be bad. It's gonna just look silly. So the easiest way to achieve really straight cut, well, the straightest possible cut, is to remember that 3 pipes on your gas cutting torch that you have, they're actually vertical, and you can use just simple square to line up with your workpiece and hold torch against the square, and this way you can achieve more or less reasonable position for cutting something heavy. It's very simple trick, but works marvelous. So again, I'm not gonna be taking time to show you everything full speed, simply because it will take ages to make a video. But obviously the heavier material, the slower your cutting speed will be, well, relatively, because you're still getting better and faster cut with a larger diameter of nozzles and so on. But generally speaking, it is a fairly slow process. I have speed up cutting some 5000%, and as you can see, guys, that the finish of a cut manual is nothing like what machine did, simply because you can't really be as steady with your hand as machine does. That brings us to the machine that we're using. There are different brands available on the market, and there's nothing particularly special about this one. So what we have in here is a forward or back controls with this switch, and the speed of a machine controlled by that knob, how fast it's going. From this side we have controls as well, where this knob allows you to lift up and down your nozzle. This one allows you to tilt it if you need to get bevel or anything, and the other one just allows you to extend how far the nozzle can be away from a machine. I forgot to mention the lever. This particular one is the used to engage gears on and off when you want to shift machine, and when you engage it, then the machine gets engaged into the gear that's driven by motor. Just like anything else in our world, in the world of welding or oxy-fuel cutting, it's all down to the amount of practice that you have. If you have to cut steel pretty much every day, you'll be really well at it, and if you have to cut it once every 6 months, then obviously you need to get your bearings around and make sure you actually got your act together before you jump onto something that is a bit more complex to cut. That's related to the machine cutting, and the same relates to manual cutting. Obviously it's much easier with a machine, simply because machine can go at a steady pace and you don't have to worry about it. You can just set it and let it go and it will cut perfectly everything you need to cut. So as you see now, I had the flame on, and then I just open up the cutting oxygen. At the same time I switched on the switch to move direction, which direction I want to cut, and you can see machine cutting away nice and easily. That's pretty much the normal speed for that sort of thickness. You could probably go a little higher again with it if you set stronger flame, but it will come to the point that the thickness of material will actually limit how well you will cut unless you preheat it, as I mentioned before, from the underneath. So then the material will heat up through a lot better, and you have much cleaner cut. But at this speed, the cut that machine does is pretty good, and it's well acceptable by any means. It doesn't take much to clean up. Unlike with the hand cut, it can be quite a lot of effort to clean up nicely. If your heat set up really well and your cutting speed set up well, there'll be almost no dross left, and whatever dross will be left on the material after cutting, you can easily remove that by scraping or lightly knocking. And as you can see, I shut off the cutting oxygen, feed oxygen, and then the very last thing I'm always shutting off is the fuel gas. And I already explained my position on that and my reasoning on that as well, so you guys can have pretty much, you can argue with it as much as you like, but I kind of made my mind over it. You can see the finish of the cut, and as I mentioned before, it is rather easy to clean up, and in my case I'm just using sparker to clean up some of the light dross, and you can see it's a very clean cut. Some applications may require you to have very clean and sharp edge of a cut, and that can become quite more difficult, because to achieve the top edge sharp, that means that your heat needs to be hot enough to burn good, and it's cool enough not to melt the edge. And there's it comes with experience, and if you don't really do much, it's very easy to muck it up. Here is what can happen if you're just a little bit of low on the temperature. If you're a little bit too cold, you can see the top edge of a plate that's been cut already is good, but halfway through the middle of the thickness, it's starting to crop. On the other hand, everything becomes really easy if you can leave with the edge like this one. If you don't need a sharp edge on the top, you can crank up your temperature really high and just blast everything through, and you can see how smooth the finish is. The good indication that you are actually cutting really good is the sound that you get, the sound of the cut, and also the way that the material get washed away underneath the plate. So listen to that. As you can see, it's a nice consistent fountain of oxidized steel, and there is no dross left after the plate was cut. There is no bridges or anything like that. If you are cutting really thin material, sometimes you can make heat so hot that it will actually weld right behind you, so you need to be careful with that. And as I said, everything comes with experience. You got to play with it. This plate is 50mm or 2 inches Hardox 500 plate. It will be blade for digging bucket standing further on in the workshop, and it's the same type of steel that used for bulletproof vehicles and stuff like that. And it's also extremely grind resistant, so it works really well for excavation equipment. As you can see, as I mentioned already, it's a really strong fountain of very steady, very clean, of oxidized steel flying away from underneath the cutter. Remember, those nozzles can cut up to 300mm or 12 inches, and they can cut with a pretty much same quality, so it's not a bad finish. Little iffy start in here, but hey, it worked out alright. The digging bucket did not complain anyway. Now you see me using the rosebud with the oxy propane mix. and it's just perfect tool if you need to throw lots of heat into a material and preheat something really well, because the temperature you can generate is phenomenal. Again, there is various different sizes of rosebuds available, but if you need to preheat something, that's very really good tool, and it's one of the main reasons why I use propane, because it's a lot easier to use rosebuds on a propane. At least it's a lot easier to buy them and where I am, and that's pretty much it. Some people may think that preheating hard dogs prior to welding will weaken steel or have some other ideas of that nature. That's actually not true. If you look at the hard dogs and you get the data sheets, it actually tells you that depends on the thickness of material that you have your hard dogs at, you need to preheat to a certain temperature, and that's pretty much what I'm doing at the moment. Sometimes when you cut relatively thin steel like this, 25 mil, well, or thinner, what you may have is due to the travel speed and the heat, there isn't that much of material that you can generate being removed during the cut. So what you may end up is not having such a strong fountain as you've seen when I was cutting 50 mil steel. But what you will see very steady stream of steel coming out from a plate, and it also will carve forward in the line of cut, so it will carve in the same direction as you are cutting. That happens is because the jet of cutting oxygen that comes through the gap is actually touches up on the front on the leading edge where it cuts, and it creates drag, so it actually curls forward, and you'll be able to clearly see that in this section of the video. So pay attention and you should be able to see it really well. And I will just shut up so you can actually hear the noise as well. Oxy-fuel cutting doesn't really like any laminations or dirt underneath, so the metal needs to be clean. And if you have some of them, sometimes you can actually have, you can see the puddle, the actual cutting jet is getting swirled around, and that's the reason why it doesn't cut any further, because I stepped over a gap and there is no continuity. You need to start from a good temperature and start burning away, rather, it cannot go between different parts. It is still a good cut, just has some little dross underneath it, but that dross is very easy to remove. It's not really a bad cut by any means, and once you can knock it off, you can scrape it off if you wish to, and you see on the right hand side what you actually see is what happens if you don't pay attention to your cables and you don't pay attention to your gas pipes. So sometimes when they get caught on something while machine is driving, machine will drive itself off the line simply because it got caught on something with the cable or the hose. So this is my burning trolley, and as you can see, it has quite funny shape in it, and it also has 4 wheels. 2 wheels are on the top and 2 main wheels are on the bottom. When trolley is stationary, the bottle is standing vertically, perfectly on its basis. However, if you need to move it, it's actually fairly easy, because all you need to do is just come in, put your right foot against the wheel, and then pull the trolley towards you, and your center of gravity instantly over the wheelbase, so you can actually maneuver it fairly easy. And again, you can just set it up backwards, and when it's standing its own, the wheels are not touching the ground. So yeah, you just store this torch this way when you need for transport. One of the subscribers asked me how they transport the bottles in the van. So I just decided to include it into this video. That will be easier, and that will explain why I need those two wheels up the top. So I just drop it in the van that way, and then take a forklift and lift up the back end of it and drive the whole thing into the van. It's kind of simplistic, and also when you're working on the site, there's always somebody's on the side who will give you a hand to lift two bottles back in place, and it's actually very easy to lift with two people if both of you lifting. If one of you is actually just pretending to lift, then it becomes quite heavy, but it's totally manageable between two people, and it's pretty much how it works. So on the inside of the van, this is how it travels. So it's just has something underneath the wheel, like an angle iron I carry all the time for dropping the bottles and stuff, and it's strapped in, and it's pretty much as good as it's going to be. I need the ventilation in here, but other than that, it works fine. Let's talk a little bit about safety things in this setup. So in this type of burning gear, what I have in my case, I have non-return valves on the both oxygen and propane line, on the both fuel line and the oxygen line. As you can see, the hoses, they've seen better days, and it's time for them to be renewed soon. So again, I don't really use it that much that often. Sometimes things like this getting overlooked. So non-return valves, it's good to have a couple of backup options. This type of welding torch also has a clip, so for holding the cotton lever. So some people use it, some people don't. I never really use it, just hold it with my hand. But it's good to know that some models have. So if you need something very cutting for long distances, it's a good thing to have. The gauges, they have spark arresters on each line. On the propane line, specific spark arresters to the fuel line, and you shouldn't be overlooking these guys because it's a very important piece of kit. And the same thing happens on the oxygen. It has like porous ceramic surface in it, and the flame front has a really difficult time to pass through any porous surface, and it also has second non-return valve inside. So as you see how flame was burning straight out of the nozzle, and I'm just going to use standard metal thief, and to see you how flame front propagation actually can be stopped by a very simple device like this safe mesh. As you can see, there is no flame can travel all the way down to the nozzle. Everything burns above the safe. It's a very interesting experiment, and not many people know about this sort of thing. So when you start your cutting, you have two gauges, gauge on a bottle in my case, or left gauge on this type of gauge. It actually indicates pressure inside of the bottle, and the gauge on the right hand side indicates pressure, working pressure inside of the hose. Your gauges should be unscrewed anti-clockwise, meaning they're putting zero pressure into the working lines. Once you open up the bottles, and then you can slowly release pressure into your working lines. In my case, I will set up about 3 bar of pressure on the oxygen side of things, because I'm using the 3/64 cotton nozzle, and it seems to be like a good pressure for it. It works really well for me anyway. I have to say that all of this business on cutting is very intuitive and very much down to your own experiences. So if you just starting off with this, it will be sometimes easy, sometimes hard, but you'll need to get your hand and you need to wrap your head around it. So on the propane side of things, I will put 0.4 of a bar, about 3 psi of pressure, and that will be sufficient as well for this sort of things. Also have to say that older type of gauges that similar to what you see on the propane, those gauges can be mounted on any bottle like argon or CO2, and also an oxygen bottle. And the argon and CO2 and the nitrogen, the system that compresses gases, they don't work to the same purity as the oxygen compression systems. So if you use same gauge on the argon or any other gas and then put it in an oxygen bottle, it may have some oil particles in it. So when you put it on an oil bottle and turn it off, the gauge can explode. It's a horrendous experience, and nobody wants to see gauge clocks going through their mind in the last moment. So you really need to pay attention to that, otherwise you may find yourself in deep trouble. Let's talk about setting up the flame so you'll be ready to cut. First of all, it's a brand new nozzle, 5/64, and I already told you the pressures I'm going to be using on the gauge. You set your heat by not by any specific parameters, but rather to adjusting to the thickness of material that you have, and that has to come to you with a little bit experience. So you've got to play with it. You can't just jump out with both feet without any experience at all. So I lighted up the propane, and as you can see, there is quite lots of red flame and lots of soot, black carbon flying off, because not all propane burns really well, and there is lots of soot. And the flame are similar to what you see in a fire, coal fire or burning wood, very red flame. When I will start adding oxygen, you will start seeing this flame starts to get a little bit more bluer, and it starts to go a little bit more clearer, more towards transparent side of things. As you can see, the flame is a little bit farther away from the end of the nozzle, and then it just pops back into place. Propane is quite difficult to light up on the wind, especially because it's very easy to be blown away with the wind. So once you start to establish yourself a little bit, that flame needs to be right close to the nozzle. Adding a little bit more oxygen, and you'll start seeing flame getting clearer and clearer. And what you also see in this oxygen, you can see purplish kind of flame with a bright blue core of a flame, and the little streaks in there. That's a still indication there is a little bit too much fuel in this fuel mixture. Purplish flame, the widest part is a flame that protects the molten metal when you cut from oxidization, and right now I'm increased so much oxygen in it that just too rich with oxygen. You can see everything becomes very clear, and the core of flame, the brightest part in there, right in there, is actually very, very crisp and very, very sharp. And in this case, the flame has far too much oxygen, so not all oxygen burns through. When you cut with plate like this, with a flame like this, it actually oxidizes steel a little bit. So you need to find the balance somewhere in between. And good indication to do that is you start getting very, very specific glow, and when you hit that cutting oxygen, it should form nice and straight jet, as straight as possible, as long as possible, as even as possible. If you haven't cutting oxygen and your core of a flame, those widest parts do not move when you hit cutting oxygen, that means you're just a little bit too much on the oxygen side. At the moment I'm too rich on the fuel, and if I add a little bit more oxygen or take away a little bit less fuel, this looks pretty good, and it has very specific sound to it as well. So when it comes, I'll just shut up so you can hear exactly how it sounds. And you can hear really nice jet forming. The torch cutting is not by the heat, but instead it cuts by this jet of oxygen. The ferrous steel has ability to burn in the oxygen environment at a lower temperature than it is actually than its melting temperature. So all you do is just burn away that steel with that oxygen jet, and that's the reason why it doesn't work on the stainless steel or aluminum, because the oxides that you get out of those materials, they actually melt at much higher temperature than parent material. So again, what I'm going to do, I'm just reducing the level of oxygen in the flame, and you can see, and now I just increase a little bit more propane, and it's almost blowing away. So when I add oxygen, it pops back in. But if you're in the wind at the moment, that would be just get blown away. So you really want to have your flame to be as close as possible on the nozzle. It needs to be on the nozzle, not off it. And then just adjust it. Yeah, and you can see really, really bright glow at the end of it with a good formation of a jet. And that will be really good setup. A little bit too much on oxygen side of things at the moment. and it looks a little bit at somewhere in the middle, just a little bit too much on the propane at the moment, so somewhere in between. Let's have a look at the samples of some manual cutting on different thicknesses and how heat affects it. If you remember, I have 3/64 nozzle which is supposed to cut anything from 5 to 12 mil, and what I have in here, I have like 3 mil plate, 12 mil plate, and 25 mil plate. So it's about 1/8 plate, half an inch plate, and an inch plate if you live behind another side of the pond. Okay, so what I'm going to do, I'm going to just lay out a piece of steel or something underneath, because I don't want to damage the concrete floor with molten metal, as it's going to be dripping around, and we should be able to set up and cut. I will attempt to keep a small flame as possible and to have fairly high travel speed in order to cut this very thin material, but from experience I know it never really works that well on in my hands anyway. Some people may be way better than I am with it, but for me it never really works that way. You don't have to start from edge, you can start from somewhere in the middle, as long as you can heat up the steel to a high temperature and then put clean jet of oxygen in it, then the steel will be born in the oxygen environment, kind of similar to what you have to the charcoal in the barbecue when you blow at it, and that's pretty much how it works. It just burns that way, that steel. If you do have going to start from just a blank place, it's as soon as you hit cutting oxygen, you need to start moving so the molten metal doesn't blow back into the nozzle, especially that nozzle also sucking metal in as you start cutting. I know it's kind of counterintuitive because you're blowing the oxygen away out of it, but it actually creates suction, and I have experiment that you will see later on in this video to prove that what I'm saying is actually right. It's a lot easier to start from the edge, because on the edge there is always edge which you can easily heat up and start cutting from there. You only need very small bit of material to get to the temperature, like really hot stuff and white hot even, and then once it's there you can pick it up and start cutting. Instantly, as soon as I start cutting, you see that area around the cut is actually glowing red, and that's too hot, and that's the reason why the metal is just fusing behind me, it's welding back in. So what I need to do, I need to start traveling a lot faster so I don't put so much heat into the material. And again, it's not the easiest task for me, it's just simply because I don't really have that much experience cutting such thin steel with the burning gear. But again, if you practice anything, you'll get better at it. Just doesn't feel natural to me. And again, you'll see that travel speed needs to be fairly fast. It doesn't look very good. It looks like there is a bit of a drought in there, and it's not really particularly interesting cut as it is. And I'm just gonna, because I already have a hotter material, I will try to pierce a hole in the middle so you see exactly what I mean with the movement the moment you start hitting the cutting oxygen. I'm trying in, and yeah, it's glowing red, and at some point it will be ready. It can also be very counterintuitive, simply because having the low flame means that it will take long time to actually get to a temperature when it's ready to burn, and because material is so thin, that heat travels all around the material and heat affected zone is really big. And as you can see, I keep trying, but I cannot pierce through such a little thin material. And when I do so, look how much glow they have around the whole thing. And my cut, it seems to looks alright, sounds alright, but I'm actually fusing. I can see myself parts getting welded behind the cut, simply because everything is so hot. So I do really need to increase the speed of travel, and I'm just simply not comfortable with it. Not comfortable simply because I don't have enough experience to cut such a thin steel, and it doesn't work. It doesn't work for me. Yeah, totally welded. The only way I can make it work for myself is to increase my travel speed quite dramatically, and I'm just out of my comfort zone because I wouldn't be able to follow any pattern if I did so. So that's pretty much what it is. I didn't quite like the cut either. So same flame, but now on a slightly heavier half inch 12mm plate. And if you start from edge, you just need to pick up the any sort of small piece on that edge that starts glowing white hot, and you can start cutting from that. And as you can see, there is quite easy cut from what it is. Still quite cold for this sort of a thickness of material. It would be better to increase temperature, which I will do later on, and you'll see the difference as well. But for some reason, I think it's easier to start from a lower temperature and going up. I will have to wait for a little bit more because you have a little bit more in control, rather than you have to run like a headless chicken because you're too hot. And you can see it's fairly clean cut out of that. So if I'll increase a little bit more, add more propane, and then adjust oxygen, add more propane, adjust oxygen, and then I'm going to be a lot more hotter. Plus there will be some heat in the plate now, and you'll see the difference. Remember when I said that molten metal, when you having a good cut, molten metal will be flying carbon forward into direction of travel, and it should sound like a jet plane just a little bit. Yeah, and it's fairly clean cut. According to manufacturer, this is the maximum thickness of what this nozzle should be cutting. However, if you remember, the jet on this nozzle was quite long, and this nozzle would easily just snap through this thickness if you're simply, I'm gonna cut it off so you'll see exactly that it can cut through much bigger thickness. As long as there is enough of that jet to cover the thickness that you need to cut, you'll be absolutely fine, and this nozzle can take it. In fact, as you can see, it's either me or a nozzle, but this nozzle or me cutting heavier material a lot better than cutting really thin stuff. I'll get rid of this plate and we'll try small cut on 25mm with a pretty much same adjustment on the plate. And as you can see how when I heat up a plate, you can see sparks flying around because rust popping up, and sometimes it just gets sucked up right into the nozzle. And once I've finished cutting this one, I'll show you exactly what I mean by nozzle creating suction as you blow oxygen out of it. So the same flame as I was cutting in the previous plate, just try it on the edge, heat up through the depth of the steel. Bear in mind 25mm plate is twice the thickness that what manufacturer says this nozzle should be cutting. So it says from 5mm to 12mm it should be cutting, and we cut in 25mm, and as you will see, it actually cuts really well. Again, because the plate is quite heavy, it takes a minute to heat up, but usually I'm running it low, but you should really aim in for start cutting from the moment you touch with the torch to start cutting within 7-8 seconds. But for some reason I have this preference that I can't get rid of out of my head, and I need to keep it colder for some reason. It feels more natural to me. I feel like I have more control this way. It's a nice clean cut. It works for me anyway. So what I'm going to do now, I'm gonna take just some coin. I'm gonna put this in the center of the screen, so I know exactly where center of screen is, and I'm gonna use the chalk and make some powder and make that powder line around the coin. So when I start blowing with the torch onto the coin, you will actually see which direction the air mass moves, and the fluid dynamics on the what's happening in the nozzle is actually quite fascinating. Simply fascinating. Just the physics, you'll get Venturi effect that creates vacuum from a fast moving oxygen jet, and it's just fascinating to watch, because as I said, your mind can wrap it around it. So I really hope that somebody actually is going to watch this video, especially this far up to the end. It's probably the longest video I ever done, but I really hope that it actually helps somebody, because it does take a bit of effort to create this video. As you saw, all chalk just blown away, and you can see the coin clearly sticks to the bottom of nozzle. And if you get it really flat, even on the both sides, it lifts up really nicely, and you can hold it for quite a long period of time, move it around and everything. But when you lift it up, it's obviously creates more turbulence, and then the coil just falls. That's pretty much it for me on this video, guys. Thank you very much for watching. I really hope that, as I said, you find it interesting or maybe helpful and learn something from it. If you still have at least a little bit of strength in you left, and you're a kind of curious person who likes to see why like draws from a burning gear, from all the burning that we've done, was it black color when the common rust is brown, and what's common between a bullet out of a hunting rifle or a sniper rifle and welding and things like this. I really would like you to visit my website and the blog page on it, and I have what I consider to be quite interesting blog posts in there, and not many people actually seen them, so I really appreciate if you guys have a chance to have a look in there. Thanks very much once again.